Hi, my name is Stéphane Cerveau, and with Hyunjun on my side, we are both working. We are both a software engineer at Igalia, and we are both working on a Vulkan video this year. So we'd like to present you our work on Vulkan video. So we implemented an H.264, H.265 encoder using the Vulkan video extension. And we'd like to give you our feedback and do a recap of what Tony already presented. It's going to be from the Mesa side with Hyunjun, and to the GStreamer side, to the application side. Yeah. So on the agenda, first, I'm going to make a summary of what already said Tony brilliantly. It's like the idea is like to present you what is the Vulkan video and what is what we have been actively working on closely with the TSG to propose a solution on the Mesa side. It's going to be using Intel NV and the GStreamer side. But first of all, let's talk about Vulkan video. So it's as we already know, the idea is like to be close from the graphics and the display, and avoid like to have like different framework to interact with the video and graphics. So the idea was to propose a solution where you can directly encode, decode contents and interact with the graphic display and GPU facilities. So it's very highly optimized, very low level. That's why we offer like a stateless codec, H.264, H.265, AV1. VP9 also is on the to-do list yeah, it's going to be soon available. The idea was also to be definitely cross-platform, supporting either Linux, Windows. I don't think macOS is on the shortlist because yeah, it's kind of, I would say, difficult to have like a stateless codec on macOS. But yeah, on the other platform, it's going to work fine. And the idea is like to have also the possibility to have vendor-specific behavior through capabilities to give like more opportunities to have more power or less resources, and then decide how the encoder should or the decoder should behave. So a little bit of the timeline of the Vulkan video TSG. It has been initiated in March 2018. Provisional extension has been released in 2021. There's been very hard work from the AHV, AMD, Intel, NVIDIA, and also open source operators such as Igalia or Collabora, for example. And we also actively work to have this provisional extension released in 2021. In 2023, in January, we finally released the decoder extensions, including H.264 and H.265, AVC or HEVC. And in December 2023, a month or 2 months ago, we finally released the Encoder extension. And as you may know, 2 weeks ago, I think we released also the AV1 decode spec. A little bit, little scheme on what is video encode. I guess, you know, as Tony already asked, we are not all familiar with encode. To give a little bit of what is encoding, is like you having an iframe, so an intra frame, a self-contained frame. This frame is going to be encoded totally, and then we're gonna have P frame and B frame. So P is for predictive and B for bidirectional. The idea, like to, as you see with the car, the idea is like to encode the movement, the temporal difference between frames, and not like encode all the frame totally as an iframe is. So as you can see, there is like a relation between, and in the use of encoder, and we had to deal with this temporal timeline in a sense that how we're going to feed the encoder for an iframe or for a p-frame. The idea of the p-frame, as you may understand, is that it's going to encode less information, so we're going to save bandwidth with this kind of frames type. Now let's have like a description of how it works in Vulkan. So that's the same scheme, but a little bit of recap is like where is the application is in blue. The application is going to deal with the state of the encoder and also with the data stream. So it's going to disencapsulate unpack the data from the, no, sorry, that's the decode side. On the encode side, we're going to receive raw frame. So it's going to be YCBCR frame or YUV frame or RGB frame. So we're going to transform it to something usable by Vulkan. First of all, we're going to create the session to tell that we want a specific encoder, such as H.264, H.265, AV1. We're gonna prepare the buffers to be encoded. So first of all, we're gonna set the rate control, the quality, what we need to know about what we're gonna receive from the encoder. When this is ready, we can start to encode. That's the red blocks, where we're gonna receive the raw frame and push it to the encoder queue. And then out of this, we're gonna get the VK buffers. We're going to be encoded contents and also the sequence headers. So the header representing the stream, which is going to be used by the application to encapsulate then the encoded buffer. So it can be streamed or it can be like a file, anything that the application will take care of. So next we are going to introduce Hyunjun. He's going to talk about the Mesa project.
Yeah, hi. I'm Hyunjun Ko. I'm working for Igalia and working on Vulkan video support in Mesa project. So, sorry. Today I'm going to talk about the status of Vulkan video encoder support in Mesa project. So, first of all, I'm going to talk about what Mesa is about, and then talk about history of the development for this feature, and then about the current status of the Vulkan video support in Mesa projects. And then I'm going to share some of my experience that I have had along the way. So you could get a sense of what it's like about working on Intel GPUs. And then also share about the challenges that I have faced so far. And lastly, the plan for this year. So Mesa, actually, tomorrow morning, my colleague Iago and Faith are going to talk about this in detail. So I'm going to talk very briefly this time. Mesa is a project began as an open source implementation of the OpenGL on Linux. And now people in this community are actively implementing Vulkan specification on various GPUs such as Intel, AMD, Qualcomm Adreno with reverse engineer, Raspberry Pi, Imagination Technologies, ARM Mali, or even NVIDIA with reverse engineer. So most Linux graphics developer are contributing to these projects very actively, including Igalia, where I'm working for, and Intel, Google, Collabora, etc. History. Dave, who is a talented open source developer, started in 2022 on AMD GPU first, then then Intel GPU later. He tested with FFmpeg that Lin, who is another great multimedia developer, worked on. And you can find the link, his blog post about describing the situation at the time. And then later, Igalia joined on this feature. Right after next to me, Stefan and Victor, he's not here though, started working on GStreamer. And Charlie sitting here started working on Vulkan CTS. And I, Hyunjun, and that's me, joined in 2023 and started working on Intel GPU. So Dave could fully dedicate to AMD GPU RIDV. So just for your information, RIDV is a kind of code name of AMD GPU open source Vulkan drivers, and AMV is a code name of Intel GPU's open source Vulkan drivers. So now the current status. First, Dave implemented 826 Pro on both AMD and Intel GPUs, and then I implemented 826.5 decoding, and all of them landed in the middle of last year, and then we started working on encoding, and Dave, Dave, these are almost ready for now, and Dave already opened a module requests for RIDV, and I am implementing encoding on Intel GPUs, and it generally works right now, but there are still some issues that have to be fixed right now, so that's why it's still in my personal branch. But hopefully I could fix them and open new module requests very soon. So you can take a look at this table, and you can get a clear idea of where we are. So now I'm gonna describe what I've been working so far. But I'm not gonna talk in detail about this. But as I said just before, I dived into Intel Vulkan drivers in 2023 and started working on 826.5 decoding first. After I made it land, I started working on encoders. First of all, there are tons of documents that you have to refer to because there are lots of generations of Intel GPUs. So you have to find out, you have to find what you're looking for in these documents and run video relevant commands on the specific GPU. So you have to choose one packet generation that is being widely used recently out there, and you have to start to learn a lot of video commands. Actually, honestly, it was painful, but definitely it is not horrible, but thankful because it's better than nothing because compared to things like reverse engineers, this is God blessed, right? Especially for open source developers. And then again, thankfully, there is a source code of Intel VA API drivers. VA API is kind of the existing interface for playing video on Linux, and Intel VA API drivers work very well now. So that means you can refer to the source code when you don't understand the documents or when you're looking for other information that can't be hardly found on the internet. So yeah, here's an example of the command streams for 826.5 encoding, and I'm not gonna explain like what each command is doing, but I wanted to show just what it looks like. So your work is to assemble these commands correctly with all required parameters, which is passed from applications, correctly set. Yeah, and send them to the kernel, of course, according to the Vulkan specification. So when working on this, you have to be very careful when you complete each command. Otherwise, you're gonna get a GPU hang or even whole system down. And of course, there is a way to fix this. You have to read documents again very carefully and find out which part of your command stream is wrong. But it's not that easy. But another easier way is dumping whole video commands from VAPI drivers into a file and then compare it with commands that you have created. In this way, I fixed several crazy GPU hangs and obviously made me keep going forward. On the other hand, there's a benefit of working the existing major project like this A and B. For example, this kind of the existing infrastructures of A and B made me easy to handle Vulkan memories and Vulkan images. And also there are kind active A and B maintainers, and thanks to them, I got proper read from them, and I could make it land on time. And at the beginning, I tested with FFmpeg that Lean worked on because their GStreamer and Vulkan CTS were under development at the time. But as they were getting mature, I could get a chance to test my implementation on with various applications that uses different parameters or different setups. So and that makes me find bugs easily. Challenges, GPU hang. Yeah, GPU hang always made me frustrated because there are not enough useful tools to investigate. So, but as I said, dumping command stream from VAPI drivers helped me keep going forward. And also another thing is there are lots of generation of Intel GPUs, and that means each generation might have different commands or different parameters, different memory size, memory alignments. So that's why I have to choose one target generation and focus on it, and then expand other generations. Plan for this year, landing this encoding should be my first work for this year, and then I could start working on AB1 support. And also, I'm not sure, but for the moment, it might be possible to work on another GPU for Vulkan video support. I'm not sure for the moment. And that's all from my side, and Stéphane's going to talk about GStreamer.
Hello again.
Yes.
One question?
Yeah, I got one. So I really appreciate the work you guys do. I just want to clarify that the work those guys are doing are like when recording command buffers is submission. That's why it's so challenging, because any commands you're submitting for recording is submission from the API side. Those guys have to deal with hardware specifics, different generations, and so forth, as well as to make sure that whatever bad stuff you pass in works and and doesn't cause any hangs. So I appreciate the work you guys are doing on this side. So.
Thank you.
So yeah, after the driver side, let's talk about the application side. So as Hyunjun mentioned, we had also FFmpeg, and this year we dedicated our time to work on the GStreamer support of this Vulkan extension. And so first of all, what is GStreamer? So who knows about GStreamer here? Not that bad. So it's a multimedia framework, a 20-year-old multimedia framework. It's a cross-platform. The idea is like to have like a black box system where you interconnect elements. You have three types of elements: the source, the transform, and the sync element, and you interconnect it to basically stream a media. Or to transform a media, so to decode or encode or transcode. It's native, it's multi-platform, highly optimized, so it was definitely a very good pick to test hardware accelerated codec. There is already support for VA, for DX12, but it was also very good, like to have the idea of what Vulkan video is capable of with GStreamer. So to give you a little bit of an illustration of what is a GStreamer pipeline, we name it a pipeline in the sense that it's like the data is flowing over this pipeline. You're having the video test source. It's going to be this pattern, and here you're having you upload this pattern in this raw frame to the Vulkan memory space, and then you encode it, you decode it with also Vulkan, as you may see on the fourth block, and you download the result and you display it. That's what we see on the screen on the right bottom. So what is the status for the Vulkan video support in GStreamer? Right now, you can follow the Vulkan video status. We created a page where we talk about the open source support of Vulkan video. So you might have like all the updates and what we support right now. As you may see on this slide, the H.264 decoder has been merged the last year in December 2023. It is now ready. H.264 should come soon as AV1. Regarding the encoder, that's the purpose of this presentation. The review is ready to be merged or reviewed still. There is like some issues still, I guess, we need to tackle. But yeah, it's ready to be used and tried if you want to give it a try. It's supporting H.264 and H.265. A little bit of the state machine. I hope you can see something on the screen to fit on the vertical side. It was complicated. So the idea was like to have on green what you need to do if you want to start the session. So you need the video session telling what are the resolution, what is the resolution, what is the codec you would like to use. Then you initialize the session parameters such as SPS, PPS, VPS. Then you reset the codec state of the driver to tell like you are now ready to start an encode queue, and you can change the quality on the fly. You can retrieve the session parameters if they change. You can probe the driver to know if there is new session parameters. You set the placeholder for the current frame, and then you start to encode the buffer. You query the result and you repeat the scheme. So let's talk now about the challenges we have been facing this year using the Vulkan video and GStreamer. It's a cross-platform API, so various behavior between various hardware, Windows, Linux, NV, NVIDIA, RADV. So first of all, we had to tackle all the issue validation layer were like giving us, and it was very useful because a lot of crashes were because we were not using correctly the API. So thanks to validation layers, it helped me a lot, like to understand what I was doing wrong. So exact behavior, as I said, can vary between hardware vendors. So on one hardware, we can have like one queue doing everything. On the other hardware, we have to use separate queue. That's typical issue we have been facing. The quality can be different. The rate control behavior can be different between the platform. In one platform, I was having a very low quality at the beginning, so I was suspecting using incorrectly the standard parameters. It was a different behavior between hardwares. So yeah, it was a back and forth to understand why it was not working properly. CTS helped me a lot with that also, to know that I was properly using the standard parameters. Synchronization. So yeah, all memory from Vulkanised 2022. I can tell you that we have been like struggling to perform a demo and getting like some green screen. I don't know for we're here. So now it's fixed, but it has been also an issue with the encoder. So we work the GStreamer state machine for the memory barriers, fences, or what is done to achieve the synchronization inside the GStreamer. So there is a GST Vulkan operation object to handle the common synchronization. It basically do everything you need to achieve a common buffer and wait for the correct state of the common buffer achievement. I've been also struggling with the DBB management. So I see that it's already 10:30, so I'm gonna be quick with that. But it was like the main issue I had, like dealing with IPv frame, dealing with the reference slots, be sure that what I give to the begin command was correct according to what the standard parameters were, and what the encoder command was performing. I had a lot of crash with that, and yeah, it was not always detected by the validation layers. It was typically when I was using incorrectly the standard parameters, so I was having a really miscellaneous crash. It helped me to have also various implementation. I could compare the behavior and see that I was having a crash here, not crash, or having a log here, and yeah, having a multiple implementation was useful. So yeah, it was a very challenging part of this encoder implementation. So the Vulkan tooling, thanks for the tools available in Vulkan. Validation layer was the main one I've been using. I was always afraid of receiving message because sometimes kind of hard to understand the wording. But yeah, when I was having nothing, I was like celebrating with a beer on Friday night. It helped me to understand the specification. So definitely you have to enable the validation layer to understand what your code is doing. Do not prevent the misconfiguration, as I said, for standard parameters. In this case, Mesa driver helped me a lot to understand where I was having driver pitfall when the implementation was incorrect. I used a lot of graphics reconstruct. VK layer energy API dump also helped me a lot. I compared the implementation, FFmpeg and CTS, where CTS was the most advanced software regarding the support of encode. It helped me a lot to compare the parameters and see, okay, here I'm having this, here I'm having that. It was very helpful. So yeah, as I said, CTS was a very helpful software. I don't have demo. I don't have the computer, but you can come to me and check that it's working. We're having like with this software, I can provide you like a demo like privately. And do you have any question? Do you have an interest on
we
this
can
work?
cut into the break for a little bit if there's a couple questions that you want to ask.
Hi, I probably missed the slide when you were talking about validation layers, but I have a question related to that. Are there any validation layers which validate the usage of Vulkan video?
Yeah, yes, definitely very accurate.
Or is that something which has been recently added or?
Yeah, it's been released. Yeah.
Okay. Okay. Yeah.
CTS is not released, but I think it's going to be a question of days to be released, but the validation layer is definitely available.
Sure. Yeah, that's helpful. Thank you.
Okay, we'll do one more.
Is very fast. I saw that you said H.264 support in GStreamer. H.264 decode was ready.
Yeah.
What's the status of H.265
It's
decode?
going to be ready. I mean, it's going to be released this month, I would say. Yeah,
Thank you.
really quickly.
Just one more comment. I really appreciate Igalia work on everything, not only GStreamer. Now, a lot of you guys know that in order for us to pass the standards, we have to have CTS develop, which is testing the pipeline for the encoder and decoder. And Igalia also helped a lot on this side. So otherwise, you can't release standards. Validation layer as well. Validation layer is something that verifies pretty much the KHR side, not the standard side, by the way. Be careful with this. And when you enable it, it's a little bit frustrating because you enable it and you start getting those crashes with cryptic messages a lot. And then you have to figure out what's going on, but it gets slapped to the hand. It's like, no, you're supposed to not do this. And you have to figure out what exactly. But so yeah, this is type of challenges when you develop frameworks. So for you guys, when you start using the APIs and the frameworks, it should be much simpler and easier to work with. I also wanted to just also say that Valve has been a big supporter in sponsoring a lot of those projects, but Igalia as well. Really appreciate Valve's help. I just wanted
Thanks
to
for
shout
the
out.
sponsorship from
Thank
Valve.
you. Thank you, guys.
All right, round of applause for these guys.
Fantastic.